So today, the big topic that I want to build up to is scales and modulation. Modulation being the technical theoretical term for changing between different keys or between different scales. And that might sound like a big change of topic for this lecture series, since so far we've spent 3 lectures talking about chords, and specifically just mostly major and minor triads. But the big lesson that I want you to get from today is that scales and chords aren't very different. In fact, from our perspective of voice leading, scales and chords are basically the same. And of course, that's a familiar idea from chord scale theory in jazz or jazz pedagogy. But I'm going to mean it in a slightly different way than chord scale theory means it. Chord scale theory sort of says that you can take a chord and you can flesh it out into a scale. I don't necessarily want to think about it that way. I'm going to say that if you think about chords as like 3 or 4 note objects and scales as like 6 or 7 note objects, they behave basically the same way, just with more notes, even though they have different numbers of notes within them. So to build up to this topic, we're going to start with a general rule for finding the smallest voice leading, which is something I've been hinting at and promising for several lectures now. You'll remember that in my last lecture, we built up to that diagram cube dance that I was already showing. But that focuses just on specific types of triads, major, minor, and then eventually augmented triads. We're going to want a rule that will guide us for any kind of collection of notes, whether it has 2 notes or 3 notes or 7 notes or, in principle, 19 notes. We can actually formulate a general rule that helps you to find the smallest voice leading between chords of any arbitrary type. Then we're going to talk about modes of a scale and why the concept of modal brightness works for the familiar diatonic modes like Dorian, Ionian, Phrygian, and so on. So we're actually going to find out that thinking about modes of a scale relates to the general rule in a really useful and interesting way. And then finally, if there's time, and frankly I think there may not be time, I'd like to talk about how classical music uses modulation. In particular, how it uses voice leadings between scales to shape the overall form of a piece of music. In other words, I'm going to give you a kind of idiosyncratic and simplified approach to thinking about things like binary form and sonata form, if you have a little bit of background in classical music. And we'll talk about a couple of piano sonatas that demonstrate the main concepts. But we're only going to get there if we have a decent chunk of time at the end of the lecture to talk about it. Otherwise, we may have to save it for next time. So that's the agenda for today. So to get started, we're going to talk about this general rule that we need to look for. And just to remind you of what we're dealing with. Remember that in general, if you're trying to look for voice leadings between chords with n notes, so for example, if I'm dealing with triads that have 3 notes, there are n factorial, that's what the exclamation mark means, n factorial possible voice leadings between those chords that you could consider. So for instance, if we're dealing with 3-note chords, there are 6, which is 3 factorial, 3 times 2 times 1, 6 different possible voice leadings. But today, we're going to start talking about scales, which might have 7 notes, and if you want to change between scales, there would be 7 factorial different possible connections between 2 versions of a scale. But 7 factorial is 5040, so that's kind of scary. If you think about going from C major to D major, there are potentially 5040 different ways of connecting those 2 scales. Obviously, most of them are going to be nowhere near the most efficient way to do that. So that's the goal. We need a rule that will help us find, for any possible kind of collection of notes, the simplest possible connection. And the way that we've thought about this so far is we've said, if I'm dealing with the triad, I can think of that triad as having a root, a third, and a fifth in the chord. So if I imagine this stack of notes as the first chord, and this stack of notes as the second chord, we thought about the possibilities for all the different ways that you could connect the two notes. So the root could become the root, the third becomes the fifth, and the fifth becomes the third, and so on. And we saw that, again, there are n factorial different ways of pairing up the two notes in these two chords. Now, the trick for simplifying this, for not having to check all n factorial possibilities, is instead of thinking about these as just stacks of notes, let's reconceptualize how we approach this and imagine this on a circle. So instead of just these linear stacks, let's imagine that I have a root, a third, and a fifth. And the real secret here is that it never hurts to keep things in the same order. So for instance, there are some voice leadings that keep the root the same, the third the same, and the fifth the same, that they just send each part of the chord to basically the same part of the chord. That's not always true, though. Sometimes it's more efficient to send the root of a chord to the third of the chord. But then it turns out that if you're going to do that, the smallest voice leading is going to send the third of the chord to the fifth of the second chord, and the fifth of the first chord to the root of the third chord. So once I make a decision about how to connect two of the notes, the rest of the notes just have to follow in order. So this is a possibility. There are also connections that would go like this. If I take the root of the first chord and make that become the fifth of the second chord, that will force the fifth to become the third, and the third to become the root, if I'm looking for the smallest connection between the two chords. So in technical terms, what I'm saying is, if you're looking at possible voice leadings, removing a voice crossing never increases the distance between the chords. So if you're looking for the shortest possible connection, you only have to look for the connections that have no voice crossings. And this really drastically simplifies the picture for us, because it means you only have to pay attention to where the root goes, or where any individual note from the first chord goes, because all the rest are going to be forced to follow in sequence from that. So instead of having to check n factorial possibilities, you only have to check n possibilities. For triads, there will only be 3 possibilities to check instead of 6. And for 7-note scales, that means there are only going to be 7 possibilities to check instead of 5,040. That's a huge improvement, especially as your collections of notes get bigger. And usually you don't even have to check all of them, because you can kind of guess where the root or the first note is going to go. It's going to want to go something relatively close to it. So you don't even have to check all n of the possibilities. Usually it's just 1 or 2 or 3 that you're going to want to check. So for instance, let's imagine this with something slightly more complicated than triads. Let's imagine applying this principle to thinking about 7th chords. Now we know that a 7th chord has a root, a third, a fifth, and a 7th. And what I'm saying is, if you know that the root becomes the third, then the third becomes the fifth, and the fifth becomes the seventh, and so on. If the root ends up becoming the fifth, then the third is going to follow along and become the seventh becomes the third, and the fifth becomes the root. So they always stay in order. Another way that you could visualize this is if I'm saying that the root becomes the fifth down here, I could write within the circle the root becomes the fifth, which means that the third becomes the seventh, the fifth becomes the root, and then the seventh becomes the third. So I'm imagining having the same list of notes but sort of inside the circle and spun around. Let's see what this looks like in practice. So let's start by thinking about minor seventh chords. And just to pick an arbitrary problem, let's think about going from C minor 7 to B flat minor 7. And so the notes that I need here are C, E flat, G, and B flat versus B flat, D flat, F, and A flat. A flat. Now, one thing that we could try is we could say, what if the root just stays the root? That is, C, the root of the first chord, moves to B flat, the root of the second chord. If we do it that way, we go down here. That's saying the root stays the root. Then the third should stay the third, the fifth should stay the fifth, and the seventh should stay the seventh. In other words, all I'm going to do is I'm going to take all of these notes and just shift them down. And if we do it that way, then every individual note is moving down by 2 for a sum total of 8 steps of motion between the two chords. And it seems plausible that that might be the best possibility, especially since if I were dealing with C minor as a triad and B flat minor as a triad, this sort of downshift would be the best possibility. But since I only have 3 other possibilities that I have to check, we might as well go ahead and try some of the other ones. So for example, what happens if instead of letting C go to the root of the second chord, we let C go to the third of the second chord? That is, C goes up to D flat right here. That's already a little promising since that's only moving by 1 step rather than 2. Again, I can use this principle to figure out where the other notes ought to go. If the root of my first chord becomes the third of the second chord, then the third should become the fifth becomes the seventh, and the seventh becomes the root. Again, we're keeping the order root, third, fifth, seventh the same. We're just spinning them around. So here I have root, third, fifth, seventh. So the root became the third. That means that the third, E flat, should become the fifth, which would be F. The fifth, G, should become the seventh, which is A flat. The seventh, B flat, should become the root, which is, conveniently, B flat. So that'll stay the same. And here, if I think about the total amount of motion, G went up to A flat, that's moving up by 1. E flat went up to F, that's moving up by 2, and B flat stayed the same. So that's a total amount of motion of 4 overall. In some sense, twice as small as the first one we considered. And of course, you'll see here that this procedure did give us parallel fifths between the lowest two notes of these chords. That tells me that classical music would not prefer to use this connection between two minor seventh chords like this. But again, that's a separate consideration. And if that were a consideration for us, we might want to look for the second smallest voice leading between these two chords. And as I've mentioned, that's a much, much harder question. That's one of the things that makes classical harmony rather complex, is looking for the second smallest possibility is much, much harder than just looking for the smallest possibility. Now, we could go through and we could consider the other possibilities, but I think you can intuitively see that those are going to be a lot less efficient. So for example, if I wanted to think about taking the root of the first chord to the fifth of the second chord, that would be like taking C to F. And you can see that that's already moving a lot farther than the things we already checked. But just to demonstrate the principle of how this would work, if I were taking the root to the fifth, that means that the root becomes the fifth, the third becomes the seventh, the fifth becomes the root, and the seventh becomes the third. Here that's going to cause a lot of work for us. So the root became the fifth. That means that the fifth, like I said, is going to become the root, B flat. The third has to become the seventh. That would be A flat. And the seventh has to become the third, which would be D flat. The total motion here is 5, 3, 5, 3, which, if I'm doing my mental math correctly, adds up to 16. So that's pretty far from a good option for us. Or it's pretty far from a small option anyways. And you could consider the last possibility where the root becomes the seventh. That would involve C moving down to A flat. But again, you can see that that's already a motion of 3 right here. That's going to be less efficient than moving by 1 or 2. So you might already guess that this last possibility would be less efficient than a motion of 4. And it does turn out that this motion of 4 is the best option for going from C minor 7 to B flat minor 7. Let's listen to what this sounds like. So here's my C minor 7th chord, or in the voicing that I wrote. And if I take it to B flat, and that definitely sounds like there's not a lot of distance between those two chords. If I play this a little bit more like music, I find a way of arpeggiating it. You could make it sound like this. Something like that. And actually, once I know that I can do that, I can chain root motions by whole step. I could do a whole bunch of chord progressions like this. So I'm going to go from, let's say, C minor 7 to B flat minor 7 to A flat minor 7 to G flat minor 7, and so on. Like that. And you get a sort of non-diatonic chord progression using relatively nice sounding minor 7th chords. One kind of nice thing I like about this is the fact that my root motion is descending. C is going down to B flat, but the overall motion here is an upshift connection. So I kind of like it when you have chord progressions like this where the root goes one direction and the voice leading goes the other direction. Root motion down, voice leading using an upshift. Now, here's where this way of thinking about things gets kind of neat. I'm going to delete everything but the most efficient voice leading that we came up with. So we have this thing right here. I'll shift it over. And we had this situation where the root became the third. I'll go ahead and erase this and replace what turned out to be the most efficient option for us, which was root became third, third became fifth, fifth goes to seventh, and seventh goes to root. It's usually the case that there are a number of different chord progressions that use this same basic schema. So here, C minor 7 to B flat minor 7 was one possibility that uses this. Root becomes third, and then everything else follows along. Chords that are relatively close to B flat minor 7 are going to work in a similar way. So for example, A minor 7 is just 1/2 step down from B flat minor 7. Because they're close, it turns out that A minor 7 will also use the same idea. The root of the first chord becomes the third of the second chord. So here, the notes in this chord that I'm looking for are A, C, E, and G. Root became third. Fifth will become seventh, just like it did over here. Fifth becomes seventh. Third becomes fifth, so E flat will go to E natural. And then the seventh is going to become the root, so B flat will go down to A, like this. And again, for connecting these two chords, that will be the smallest possible connection between them. Those two don't move at all, that's 0, that's 1, and that's 1. So the total motion here is 2. Again, very efficient. Notice, by the way, that this kind of connection is one where the smallest voice leading between the chords is neither an upshift nor a downshift. This is a lot like when we went from C major to E major last time. The best connection between the two involves motion both up and down. And just like we saw last time with the kind of science fiction-like chord progressions, this one also is going to sound, I think, pretty cool. So C minor going to A minor. Or like that. So these chord connections that force you to go up and down at the same time really often sound kind of neat like this. So obviously, one question that you might be interested in is, at what point do you switch alignments? At what point is making the root become the third? At what point is that not the best option anymore? And again, that's a pretty tough general question to ask if you care about all possible kinds of chords. I'm not going to try to answer that right now. Instead, to give you a little bit of practice with this basic idea, I want you to think about the idea of tritone substitution from jazz harmony. Substitution. Okay, yeah, I spelled that right. By that, I mean, I want you to think about taking two dominant quality seventh chords, C7 and F#7, and try to use this principle to find the smallest voice leading between them. So that is C, E, G, and B flat, going to F#, A#, C#, and E. There should be 4 possibilities for you to check. I would encourage you to check all 4 systematically, even though some of them are obviously much worse than the others. Try to work out all 4 possibilities, figure out the total amount of distance between them. And then my question for you is, the root of the first chord, C, becomes which part of the second chord? Root, third, fifth, or seventh? Take about a minute or two to work on this, and then I'll ask you to tell me where the root of the first chord should go. All right, so what do you find? Which option gives you the most efficient voice leading for this kind of chord progression? Does the root become the root, the third, the fifth, or the seventh? Root to fifth. Perfect. And when you do that, what's the total amount of motion between the two chords? That is, what's equivalent to these numbers I write in red up here? 2. Good. So I think that tells you something about why certain styles of music, like jazz and like Wagner, like this kind of progression, because it doesn't involve a lot of motion between the two chords. Let's just grab this. So there's my C dominant seventh chord. And to go from C dominant 7 to F sharp dominant 7, we've said that the root should become the fifth of the second chord, which means that C should go to C sharp. If the root becomes the fifth, then the third must become the seventh. The third was E. The seventh of the second chord is E, so that stays the same. Okay, that makes a lot of sense. The fifth should become the root of the new chord. So G is going to go down to F sharp, like so. And then the seventh should become the third, which in this case means going from B flat to A sharp. I'm respelling it enharmonically, so it looks like the third of the chord, but it's really not moving. So that's a motion of 0, a motion of 0, a motion of 1, and a motion of 1 for a total distance of 2 altogether. Like I said, if you're familiar with jazz harmony, this is a fact that you know intimately well. But now we're seeing it as part of a more general principle. It does feel really similar to C minor 7 going to A minor 7. Notice that in some sense, they're kind of different, because C minor 7 to A minor 7, the root became the third, whereas here, the root becomes the fifth. But you're totally right that in some sense there's this sort of contrary motion where a fifth is becoming a perfect fourth and vice versa, if I reverse it. So you're totally right about that. And there is kind of a deeper connection there. I have a whole lecture planned for seventh chords where we'll see that those are actually really deeply related in some way. This is more or less where I want to leave our discussion of seventh chords for today. I think you have enough of a basis for playing around with these if you'd like, and we'll come back to them next week and see a more systematic perspective, kind of like cube dance that we saw for triads. The rotation of 180 degrees to the root, third, fifth, seventh circle also happens for a seventh chord with root motion by a perfect fourth up. Yeah, exactly. So this same sort of thing is going to apply if instead of doing C dominant 7 to F sharp dominant 7, what if I go like C dominant 7 to F7? I think that's the kind of thing that you're asking about. And that's really similar to what we did over here when I took C minor 7 to B flat minor 7 and then used that to derive the smallest voice leading for C to A. We can do exactly the same sort of thing right here. If I take my progression from C to F sharp dominant 7 and F dominant 7 are going to be really closely related chords. I just have to shift the F sharp down by one step. So I'll get rid of that sharp, get rid of this sharp, get rid of this sharp, and then add a flat to the E. Now I have a motion of 0, 2, 1, and 1 for a total distance of 4 between these two chords. So it's a little bit more distant, but this is going to be the best or smallest possible connection between these two possible chords. Notice, by the way, that this also is a progression that you'll hear in jazz all the time. This is just what happens if you chain a whole series of applied dominants together. Or in jazz, you might think of it as a whole bunch of chained 2-5-1 progressions. In some sense, these two progressions, the tritone substitution and then this more diatonic resolution up a perfect fourth or down a perfect fifth, in some sense they're the same kind of voice leading. They have the same underlying pattern. The technical term that music theorists would use to describe this relationship is they would say that this voice leading and this voice leading are individually T related. At the end of this lecture, I'll give you a citation for an article that you could read or a book that you could read that would talk about this sort of thing. But you're absolutely right. It's the same sort of pattern. And it's specifically because F sharp and F are really close to each other. If we want to hear what these sound like, here's C dominant 7 going to F sharp dominant 7. Like that, or C dominant 7 going to F dominant 7. And to me that really wants to continue like that. All right, I think this is a good place to leave our discussion of seventh chords. And I'll mention briefly that I've given you this rule, but I haven't really justified it. I haven't told you why the chord members should stay in order. That is, if the root goes to the third, we know where everything else goes. At the end of the lecture, if we have time and you want to talk about it, I can try to give you an intuitive justification for it. But for now, I think it's maybe just good enough to know that this principle applies. Because at this point, I'd like to move on to talking about scales. And to talk about scales and modes, strangely, the first thing we should do is we should go back to our ideas from cube dance last time and rethink those ideas in light of this new information. So for triads, if I'm looking for the smallest connection between triads, there are really only three possibilities that I need to consider. There's the possibility where the root stays the root, there's the possibility where the root becomes the third, and there's the possibility where the root becomes the fifth. And maybe I'll label these possibility 1, possibility 2, and possibility 3. Now the first possibility, when the root stays the root, is musically not especially interesting. For triads, a situation like the root becomes the root tends to happen in circumstances like this. For example, if I start with C major and I raise everything to C sharp major, that is, I just take a sharp and I apply it to all three of the notes. I just lift the whole chord up one semitone for each note. A situation like this, it's easiest to let the root of C major become the root of C sharp major. So that's type 1. Type 2 is a little bit more interesting, where the root becomes the third. So going down here, if the root becomes the third will become the fifth, and then the fifth will become the root. This type of progression is what happened when, for example, we had C major, root, third, and fifth, Well, let's think about this. What sorts of chord progressions might we want to do if we want the root to become the third of the next chord? That is, for example, I might imagine the root just stays C, but then it turns out that C is the third of the next chord. If we did that with major triads, it would turn out that the second chord is A flat major. And in that situation, we have this sort of motion. This was one of our special cases where I have motion down by one and up by one, neither an upshift nor a downshift. Now, this is really, in classical terms, kind of like just changing the inversion of the chord. I'm going from a root position chord to a first inversion chord. Normally we think about changing inversion as doing something like the following. Taking C major and then going from C major in root position to C major in first inversion. That is C major with E as the lowest note. So here's a situation right here where I have the root of the first chord becoming the third of the second chord, right? This is obviously not the smallest connection between two versions of C major. It's a relatively distant connection. But this is the sort of thing we imagine when we talk about inverting a chord, going from C major in root position to C major in first inversion. But just like we saw before, when you have a connection like this, you can think of other progressions as basically being like this connection, but with the second chord shifted up or down. So I could imagine inverting C major, going from C major to C major in first inversion, and then just taking that C major first inversion and transposing it down multiple semitones. So for example, let's say I'm taking this down by 4, so that C becomes A flat, G becomes E flat, and E becomes C. That is, this last chord that I'm getting right here is A flat in first inversion, A flat over C. Do you follow what I'm doing here? Basically what I'm saying is you can take any sort of progression like this one and decompose it into two steps. The first step is this sort of thing, where we took the C major chord and inverted it, and then the second step is we transpose the inversion so that it gets closer to the original chord. But let's not call this process an inversion, because actually what we're doing is we're kind of thinking about the modes of the triad. That is, C major and A flat over C are sort of like the first and second modes of the triad if you imagine the triad as just a 3-note scale. They're kind of like parallel modes, like C major and C minor as scales, starting on the same note, but treating a different note within the collection as the tonic. So instead of saying invert, we can say change mode. Go from the first mode of the major triad to the second mode of the major triad. And if you're not used to thinking about chords as really simple scales, or you're not used to thinking about modes in general, I think this may feel kind of counterintuitive, but it's actually exactly what's going on, that modes of scales and inversions of chords are really basically the same kind of thing, at least from this conceptual perspective. And it turns out that all shortest voice leadings can be thought of in this way. They can be thought of as a combination of a mode change plus a transposition. So let's think about this. Let's think about extending this perspective, again starting on C. This time, instead of going from the first mode of C to the second mode of C, let's go to the third mode of the major triad. And I know that's a weird thing to say, but what do I mean? What's the third mode of the major triad? Yes, I see what you mean. I don't want to use the word Lydian yet. The question in the chat is, would that be an F Lydian modulation? I don't want to use the word Lydian yet because Lydian I want to reserve for talking about 7-note scales, and here I really only am thinking about 3-note scales, in other words, major triads. But I see where you're going, because the third mode of a major triad is what we would normally call second inversion. That is, if I let the root of the first chord become the fifth of the second chord, the second chord is going to be an F major triad with C as the lowest note. And so I can see why you would want to use the language of F Lydian to describe this sort of thing. But for now, we're really only thinking about these 3 notes right here. And you'll notice, of course, that this is actually the smallest voice leading from C major to F major. This is the upshift voice leading between these chords that we talked about way back in Lecture 1. And likewise, as we've seen several times, this is not the only small voice leading from C major that follows this basic schema, where the root of the first chord becomes the fifth of the second chord. This progression is basically just changing mode and then transposing the second chord by 0. But I could do this. I could change mode, and then I could take this second chord and transpose it, let's say, down by 1 semitone. So that, well, okay, what's the clearest way to do this? Yeah, I think I can do it this way. Transpose it down 1 semitone so that F becomes E, so that A becomes G sharp, and so that C becomes B. So here's a combination of a mode change and then a shift down 1 semitone, which takes us from C major to E major, where the root becomes the fifth. And of course, this was our other special case of major triad progressions, where I have G going up to G sharp and C going down to B, where there's the smallest voice leading has motion in different directions. So here I changed mode from the first mode of the chord to the third mode of the chord, and then I transposed down by 1 semitone. And this is a way, I think a really good way, to understand why these progressions, C major to A flat major, and then C major to E major, are in some sense kind of special within the world of major triads. And the way that we can do that is we can understand it in terms of what happens when I change modes. So let me write for you the root, the third, and the fifth. And we're interested in what happens to these 3 notes when I change the modes of the major triad. If I stay in root position, so I go from C major root position and stay in root position, then none of these notes move. C is going to move by 0, E moves by 0, and G moves by 0. On the other hand, if I go from root position to first inversion, what happens there is the root becomes the third. It doesn't move. C stays C. But E moves down by 1 to become E flat, and G moves up by 1 to become A flat. What I'm doing is I'm building a chart to try to show what happens when I change to different parallel modes of the same scale or of the same chord. So C major staying C major, that is not really changing the mode, nothing changes. But C major becoming A flat in first inversion, this is what I had to do. Lower the third, raise the fifth. If I want to go to second inversion, that's what we did when we went from C major to F major. We left C alone because when we're comparing parallel modes, the tonic always stays the same. Here, E moves up by 1 and G moves up by 2. So what I'm looking at here is basically a chart of a comparison of all the different parallel modes of the major triad and how they relate to each other. How do I go from the first mode to any of the other modes? And there's something just inherent in the structure of the major triad that tells me that the first mode, the root position, to the second mode, first inversion, making that change necessarily involves contrary motion. Going from root position to second inversion, that on its own involves an upshift voice leading, that is merely moving up. But notice that we move up by different amounts. The third moves up by 1, and the fifth moves up by 2. And because of that, because this motion involves different amounts, when I combined it with a -1 transposition, what happened then, let's see, so what I'm saying is if I combine the mode change with a -1 transposition, then the root ended up going down 1, the third ended up staying the same, and the fifth ended up going up 1. So because this mode change involves different amounts of motion up, there will be other progressions, like C major to E major right here, that again involve different amounts of motion. But because these differences are 0, 1, and 2, this -1 transposition is the only one that I can come up with that will produce this kind of contrary voice leading. If I tried to do the same sort of thing with a -2 transposition, in that case, the root would go down by 2, the third is going to go down by 1, and the fifth will not move at all. And you can see here that's produced a completely downshift motion. So I'm saying let's convert the root to the fifth and then shift everything down by 2. That is, I'm saying let's start from here, C major. Let's convert the root into the fifth. That would be F major. And then we'll shift everything down by 2. So we would shift A down to G. We would shift F down to E flat. And then we would shift C down to B flat. So again, we have change mode as the first step. And then transpose as the second step. And what that gives me overall is this progression from C major to E flat major, which is a downshift voice leading as we saw last time. And even though this doesn't stay in a single key, you can see that it is purely a downshift voice leading because of this. Because the amounts of motions in the mode change for the chord only differ by 1. So that's a very different way of thinking about the same sorts of things we were talking about last time. I'll pause here and ask if you have any questions about this way of thinking about triad progressions. You mentioned that all shortest voice leadings between triads can be thought of as a mode change and a transposition. Yeah. But doesn't it also require, for something like the transposition C major to C minor? That's a really great question. So when we go from a major triad to a minor triad, not only are we doing some sort of voice leading, but we're also changing the quality of the chord itself. We might think of that as being like a cross-type transformation. That is, I'm changing the type of chord that I'm dealing with. Whereas so far today I've been talking about just major to major chords, or dominant seventh to dominant seventh chords, staying within the same quality. And so when I say you can think of things as a mode change and a transposition, that's specifically relating to when you're staying with the same quality of chord. If I want to deal with relating chords of different qualities, we can take a similar perspective. It requires one extra step, which basically is the step of changing the type of chord you're dealing with. It actually doesn't cause too much trouble for us, but I think to really get into how that would work, we don't have time to do that today. But we could talk about it next week. I think it would fit pretty well. I think what you would want to do, if you want to play with this in the meantime, is think about this kind of diagram. Only instead of thinking about them as pure mode changes, think about what I have to do to go from C major in root position to C minor in root position. And that would look something like this, right? The third of the chord, instead of staying the same, goes down one semitone. That is, I would lower E natural to E flat. And you can think about what the implications for that are for all the other major to minor progressions that you could do. But even just starting from there, I think you might be able to figure out what the rest of this should look like. Okay, so the basic idea from all of this is when you're staying with the same type, like major triad to major triad, or as we're going to see, major scale to major scale, you can think of the smallest voice leading as a mode change plus a transposition. Let's actually go ahead and try to apply this to 7-note scales now, specifically diatonic scales, or you might think of them as major scales. And I think the nicest place to start for thinking about this is to begin with the idea of the brightness of modes, which is a really popular, if somewhat controversial, idea, especially in the jazz world, where you can talk about the standard diatonic modes like aeolian, Dorian, phrygian, and so on, and say that they're brighter or darker than each other in a kind of systematic pattern. So for example, right here, I've written C aeolian. And conventionally, people say that C aeolian is a little bit darker than the scale that we would call C Lydian. Now, what is C Lydian? Well, the only difference between C Ionian and C Lydian is C Lydian has an F sharp. So I could draw in an accidental right there. And I imagine you have some sense of what these two scales sound like, but here's C Ionian. And here's C Lydian. Like that. The point that I want to make is that the relationship between these two scales is essentially an upshift relationship. All I did was I left all the notes that could stay the same where they were, and then I raised the one note that had to change. F went up, it upshifted to F sharp. And actually, this is basically what people mean when they talk about the brightness of modes. We could have a debate about whether we really experience a feeling or an emotion of brightness, but if you just want to use it as a metaphorical language for a technical term, that's what's going on. Making a mode brighter means upshifting it to a different mode, and making a mode darker means downshifting it. So, for example, we could imagine thinking about one of the modes that aeolian is brighter than. So C aeolian is supposedly brighter than C Dorian. What are the notes in C Dorian? Well, there's an E flat and there's a B flat. In other words, to go from Ionian to Dorian, keeping the same tonic, you downshift. You lower the third and you lower the seventh. Again, if you're familiar with the current state of jazz theory, this is not a surprise to you. But it basically just means that modal brightness is working in the world of voice leadings, specifically in the world of upshift and downshift voice leadings. If the style of music that you care about doesn't use modes, for example, classical music doesn't really use modes until you get into the 20th century, this idea is still relevant. You just would talk about it in terms of modulation. So for instance, you can think about the relationship between C major and G major as an upshift relationship. Again, C major to G major, all that you need to change is you get rid of the F natural that C has, and you change it into the F sharp that G has. In fact, that's exactly what the whole system of key signatures in music notation represents. So we can go to a really familiar diagram, the circle of fifths. And the point that I want to make here is that what the circle of fifths is really doing for you is it's giving you a map of upshifts and downshifts between major scales. If I move clockwise around the circle of fifths, I'm upshifting. So if I go from C major to G major, that's an upshift. And it's a very small upshift because I only change one note. But if I go from C major to D major, that's also an upshift where I change two notes. Similarly, if I move counterclockwise in the circle, I move this way, those are all going to be downshifts. C major to F major, I lower one note. I lower B to B flat. In the language of modes, that's going from C Ionian to C Mixolydian, or changing keys. So really what the circle of fifths is, and what key signatures are, they're essentially upshift, downshift diagrams, very similar to cube dance, only they describe keys instead of chords. Here, clockwise motion is upshift and counterclockwise motion is downshift. It's really kind of remarkable how similar this picture is to this picture. This is one of the last stages from last time. And unfortunately, my orientation was a little bit different because for this, clockwise motion was a downshift and counterclockwise motion was an upshift. But it's the same sort of thing. You can map chords or scales on a circle, and the circle tells you whether the chords upshift or downshift to each other. In fact, one, I think, really neat thing, to come back to a question from earlier on in this lecture, is notice, by the way, that if I go directly across the circle, like from C major to this thing down here, conventionally in the circle of fifths, we show two possibilities here. F sharp major on the one hand and G flat major on the other hand. And the fact that we show two possibilities here is actually representing something kind of meaningfully real in the structure of the circle of fifths. I can get from C major to this collection of notes either by upshifting, by going this way, in which case I add 6 sharps, or by downshifting, in which case I add 6 flats. And in some sense, those are different possibilities. They get me to the same place in the end, but what happens to a note is different. So for example, if I think about what happens to my note C in C major, if I upshift, C becomes C sharp. But if I downshift, C becomes C flat. So we have a tie, two different possibilities for going upshift or downshift to get between these two keys. And they're directly across from each other on the circle here. This is, I think, directly analogous to the possibilities that we considered last time, where we said, for example, C major as a triad to D major, B flat major, or F sharp major as triads. Those are where upshifts and downshifts were tied for triads. Notice that there's some similarity and some difference here, right? C to F sharp is tied both times, but for triads there are some other things that are tied, like D and B. Whereas that's not true on the circle of fifths when we think about scales. If I want to go from C major as a scale to D major as a scale, there's really only one smallest possibility, and that's an upshift. In fact, that points to something that's really remarkably nice about the circle of fifths in general, which is that every possible modulation that you might want to make involves a unique type of upshift or downshift. That is, if I start from C and I say, I want to upshift by 2, there's only one scale that you can arrive at, and that's D major. Likewise, if I say, I want to start at C and I want to downshift by 4, 1, 2, 3, 4, there's only one scale that I arrive at, and that's A flat major, or C phrygian. Same collection, just treating a different note as the tonic. Moreover, something else that's kind of special here is that for any pair of major scales, you can always find either an upshift or a downshift, or maybe both. But it's never neither. There's no connection between between two major scales that forces you to both raise and lower notes. That's different from the picture we had before, where, for instance, C major to E major, making that connection between major chords, I had to raise a note and lower a note. So this progression is neither an upshift nor a downshift. There's no equivalent thing here for major scales. C major to E major is unambiguously an upshift. There's no such thing as going up and down. That's pretty neat. And if you're well versed in music theory, you may be accustomed to looking at the circle of fifths and rolling your eyes and saying, this is really basic information, I don't know why people waste time on this. And for a fluent practicing musician, that's true. I don't blame you for having that attitude. But the circle of fifths is showing you something that's really deeply remarkable about the structure of the major scale and the fact that these kinds of relationships exist at all. Most 7-note scales don't work nearly this nicely. For instance, I want to show you what the circle of fifths looks like for melodic minor scales. You may never have seen a diagram like this before, so let's unpack it. I'm going to zoom in and start up at the top for C melodic minor. So C melodic minor has the notes C, D, E flat, F, G, A, and B, which you can represent as saying there's just this one E flat in the key signature for C melodic minor. The notes in G melodic minor, if you think about that, G, A, B flat, C, D, E, F sharp, and G. We don't normally represent that as a key signature, but I find it really convenient to do here because the key signatures essentially tell me what notes need to change as I go from one melodic minor scale to another one. And again, I should pause here and say that if you're a classical musician, you're probably trained to roll your eyes at this way of thinking about things, because classical music never just lives entirely within the C melodic minor scale or the G melodic minor scale. Classical music doesn't really use scales in that way most of the time. But I'm not only talking about classical music here. I'm really trying to start from first principles and say, what are the possibilities if I wanted to use melodic minor scales this way? And the point is that melodic minor behaves kind of fundamentally differently from diatonic scales, like natural minor or major. Because when I go this direction around the circle of fifths here, notice that C melodic minor to G melodic minor is neither an upshift nor a downshift. What do I have to change to get between these two scales? Well, C melodic minor has E flat, but G melodic minor has E natural. So I have to erase the E flat. C melodic minor has B natural, but G has B flat, so I have to lower that. C has F natural, but G has F sharp, so I have to raise this. So the connection between these two scales involves motion both down and up. You never find anything like that with diatonic scales. Kind of neat, right? And the same thing is going to be true if I try to go in reverse, right? If I try to go counterclockwise on this circle of fifths, C to F melodic minor also is going to involve both motion up and down. E natural is going to go up, or sorry, E flat is going to go up to E natural, since C has E flat, but F has E natural. Conversely, C has A natural, but F has A flat. So that's going to go down. So for melodic minor, you get situations like we had with triads, where sometimes the smallest voice leading moves in both directions at once. And if I zoom out so that we can visualize the whole circle of fifths for melodic minor, you'll see that in general that's true. If I take any two melodic minor scales that are next to each other on the diagram, like D and A, if they're right next to each other on the diagram, there's always going to be some amount of contrary motion. So for example, C sharp has to go down to C natural, but F natural has to go up to F sharp. However, if I move past my immediate neighbors on this diagram, so for instance, if I go from C melodic minor to D melodic minor, I skip a step, or if I go farther, at that point, clockwise motion really does become an upshift, just like we had before. E flat upshifts to E natural, and C natural upshifts to C sharp. So for the most part, we still could say that clockwise motion is mostly upshift, and counterclockwise motion is mostly downshift. As long as you're moving far enough, as long as the scales are different enough from each other that you avoid this problem of a scale and its immediate neighbors. I think that's pretty neat, that melodic minor is kind of like diatonic scales, but a little bit more complicated. I think that actually makes it a really interesting compositional resource to play with, because it's familiar, but just a little bit more unusual than what we're used to. That really does make it kind of analogous to the science fiction major triad progressions we saw last time. It's familiar-ish, but kind of unusual in some weird ways. So the question that I leave you with is, what's special about the diatonic scale? What is it about the structure of major scales, or the circle of fifths for diatonic scales, that makes everything work out so perfectly, that any modulation is definitely an upshift or a downshift? What is it about major that makes it work so nicely? And that's a tough question, but I think a solvable question given what we've talked about today. That's what I want to talk about either next time or the time after. So we have a question. Does the special property that I mentioned about the circle of fifths apply for any scale which can be structured as a stack of fourths? Okay. That's a great question. I would encourage you to play with that. Specifically, try to play with that using scales with different numbers of notes. That is, try to do this for 3-note scales as a stack of fourths, 4-note, 5-note, and 6-note scales. So built like the major scale, but with different numbers of notes in the stack. And see how it behaves. Do they all work as nicely as major, or do only some of them? That's definitely the topic that we're going to talk about when we come back to this. So that's a great question. I don't want to give away the answer yet. I think you should play with it first. All right, I think this is a natural ending point for today, but I am happy to talk about questions. I know that you did have one that I didn't get to. Before I get to that one, do you have any other questions about this scale stuff specifically, like the circle of fifths? Where can we find the proofs to the properties that I discuss? Thank you for asking that, because that is something that I wanted to make sure to share. Here is my bibliography for today. I was going to use some recordings, but we didn't get to them. Here are the 3 works of scholarship that I'm really sharing with you, or some ideas from them. Your question about scales that are built as stacks of fourths, this is the article that really describes that well. Aspects of Well-Formed Scales by Norman Carey and David Clampett. We'll talk about this a little bit, but if you want real mathematical proofs of this sort of thing, that would be the article to look at. The general principle we talked about today, where if you know where the root of the first chord goes, you know where everything else goes, the article that talks about that is this one right here. Scale Theory, Serial Theory, and Voice Leading by Dmitry Timochko. It's a little bit dense, so if you want a more accessible introduction to the way that he thinks about things, I also would recommend to you his book, A Geometry of Music, which is, I think, a really great book that almost anybody who has a basic grounding in music fundamentals and can follow something like my lecture today, you'd be able to get a lot out of his book, A Geometry of Music. So if you want proofs, rigorous proofs for this sort of thing, these would be good articles to consult. And actually, I think this article by Timochko offloads some of the mathematics onto a different article about different distance metrics and partial orders. But if you want more, you can chase down the citations in this article into the other articles that he talks about. Okay, so back to the other question that I've left hanging. Final comment about the background Neo-Riemannian theory. If Timotchko applied his data analysis to half versus whole steps, he would probably find they're about 50-50 prevalence. Smaller is better, and it doesn't account for the frequent voice leading occurrence in non-diatonic music these days of augmented second, dissonant voice leading, oh my, 3 semitones. That's almost like a destructive impulse like Nomad in the original Star Trek. Gosh, I love this. Of smaller is better in Neo-Riemannian theory. Better to bad in the order of 1 to 0. 0 is better than 1, better than 2, better than 3. Yeah. So I think you're absolutely right that traditional Neo-Riemannian theory, as embodied in something like cube dance, does really privilege very small motions like 1 or 2 semitones. One of the things that I find really useful about this more general perspective, something like what we've talked about today, or what Dmitri Timotchko talks about in A Geometry of Music, is that we're talking about small versus large, but we're not necessarily saying that small is better. We are saying, if I want small, how do I get it? But the same basic way of thinking is going to give me a way of thinking about larger motions as well. And, for example, we've seen this a little bit, motions that do involve motions of 3 semitones. When we went to cube dance and we talked about, for example, C major upshifting to F sharp major, one of the motions there does actually upshift by 3 semitones. So even for the case of kind of Neo-Riemannian progressions, there are times when you do end up moving by 3 semitones. And I think in general, the sort of general perspective on this is you can say, okay, well, what if I do want to explore second smallest voice leadings, or voice leadings where I do have motions by 3? And this basic structure does allow you to explore that. People in general haven't, I think, because it's useful to constrain yourself to the simplest cases first, and I think there is a natural way in which small motions are simple, but it's not obligatory. You're perfectly free to explore other possible things. And in fact, in some of the homework problems I've given you, I've encouraged you to explore those larger possibilities, more distant motions. Now, the other part of this is you say, you probably would find that half steps and whole steps are about equal in prevalence. And I think you're probably not wrong about that. I think actually, if anything, you might find that whole steps are more common than half steps. And that's because if you work within a single major scale, whole steps are much more common than half steps. A major scale has 5 whole steps and just 2 half steps. So I think that in certain musical practices, like in most forms of tonal music that do like to use diatonic scales, there is going to be a bias away from the smallest semitone voice leadings because of the scale structure that you're working within. And I think that's why it's really valuable to think about this sort of thing, to think about what is it that makes using a major scale kind of useful. Why might I like to restrict the chords that I use to the notes within a particular scale? And I think the answer to that has at least something to do with the niceness of the relationship between these scales. That simplifying the 12-note chromatic universe into a 7-note universe, picking different 7 notes for a given passage of time, actually really does simplify the tonal universe in a lot of ways, in a lot of really nice ways. And so I think that's why you might find a lot of musical practices being perfectly happy with whole steps and half steps as basically the same sort of thing, because within a major scale, they really truly are. So that encourages us to think about a theory of scales in general. And once we do that for diatonic scales, we might want to generalize that to melodic minor scales, still just half steps and whole steps. But then even beyond that, harmonic minor scales will involve augmented seconds. And so you're saying, well, what about some kinds of music that like augmented seconds in their voice leading? Well, if we have a good general theory of harmonic minor, maybe that'll help us to understand how you can use augmented seconds in your chord progressions. So I do think that there is a tendency in the way that people talk about theory to start with something. And then if you only ever work within the thing that you started with, you say, this is what I can do. That's going to be limiting. But I think that's just a failure of imagination. You don't have to stay where you start. It's just a starting point in your exploration. And then you should explore outwards from there. I think a lot of people just sort of treat theory as, I learn this thing and then I do it over and over and over. And I think that's not creative enough for music. You should say, okay, I've got this. Where can it go next? So I like the impulse behind your question. Is there any relationship between negative harmony and cube dance? Yes, I think there totally is. I think that negative harmony and cube dance are really closely related to each other. They both come out of a really similar theoretical tradition, which has roots in the 19th century, specifically in a branch of German music theory called harmonic dualism, associated with theorists like Hugo Riemann. They package the ideas in slightly different ways. And in some ways, I find the way that negative harmony is explained is a little bit limiting. But if you try to generalize negative harmony in kind of the right ways, you end up with basically the ideas that cube dance represents. I'll try to give you a brief perspective. The idea that I like best, I think the best explanation for the relationship between negative harmony and cube dance is given in the book Audacious Euphony by Richard Cohn. This was in my bibliography from the last lecture. In particular, he talks about both cube dance and this tradition called harmonic dualism, and he talks about the relationship between them using something he calls melodic dualism. I cannot spell melodic dualism. And he basically suggests that a lot of the ideas that negative harmony talks about as inverting chords are really about upshift or downshift voice leadings. That if you take voice leadings that go up and reverse them so that they go down, that basically produces a lot of the relationships that negative harmony discusses. So for the simplest case, negative harmony starts from the idea of C major as a triad and C minor as a triad as being negative versions of each other. So they're related on cube dance right next to each other. And what Richard Cohn says is, yeah, these are basically opposites in the following sense. If I start from C major and I go to C minor, what I'm doing is I'm making a clockwise motion on cube dance, which means that I'm making a downshift. Whereas if I start on C minor and I move up to C major, I'm moving counterclockwise, so I'm making an upshift. They're sort of negatives or opposites from each other in that way. They're opposite motions on cube dance, which means that they're motions up versus motions down. And from there, you can generalize that basic idea. So for instance, if I were to go from C major to F minor, for example. So imagine that I had a chord progression that went like this. I can use cube dance to visualize doing the same sort of thing, but moving melodically in the opposite direction. So that is, I imagine starting from C minor, and instead of doing an upshift like I did before, I would do a downshift. C major to F minor moved 2 positions counterclockwise, so it was 2 semitones up. C minor should move 2 positions clockwise, So it'll move 2 semitones down to G major. And negative harmony would tell you that these two progressions, C major to F minor and C minor to G major, are negative versions of each other. And depending on who you're listening to, negative harmony has a sort of like mystical understanding of that, or some sort of undertone-based understanding of that. But you don't need sort of really mystical or non-scientific ways of understanding it if you think about this from the perspective of voice leading. If you just understand that this version goes up and this version goes down, they really are kind of opposites melodically, and otherwise structurally they're very similar. They involve semitone motion, 2 steps of motion either way, but it's just up versus down. And I think most of us are comfortable with the idea that melodic motions up and melodic motions down are the same kind of thing, but they're negative versions of each other in some really simple sense. So C major to F minor. Right, these two notes move up, whereas C minor to G major those two notes move down by a semitone. So they really are kind of opposites. Yeah, it is kind of like a symmetry that divides the graph, and it's a really simple kind of symmetry. It's just the symmetry that switches up and down. If you imagine taking sheet music and you flip it upside down so that scales that go up now become scales that go down, that's one of the simplest kinds of symmetry that can exist in any kind of space. It's just changing up and down. It's a reflection. And that really does explain many of the aspects of negative harmony. Cube dance gives you a different way to visualize it, but in some ways the visualization on cube dance may overcomplicate things. Really, the fundamental idea is that going up and going down are the same kind of thing, but opposites. Just like positive numbers and negative numbers are kind of like the same thing, but opposites. I guess that's pretty much everything. That's pretty much everything for this week. Next week, I guess I'm going to have to decide whether I want to talk about 7th chords or more stuff about scales. That's tough. We'll do one of the two. And then whatever we don't get to next week, I guess we have another week after that.